Welcome back. So for this assignment, we're going to look at chapter 5 from our data visualization book by Healy. And we're going to focus on graphs, tables, adding labels, and making notes, as this title of the chapter implies. So for a lot of what we've been doing so far is making basic plots, learning how to master their underlying elements using the grammar of graphics. So now we're going to focus on things like groupings, creating summaries, and layering the information a little more to create multiple visual channels to communicate. So hopefully by now you're back in your folder where you've been storing all your documents. And what we're going to do is add a new file to here for our chapter 5 homework. So just to make sure, we're going to set this as our working directory so that we know everything saves inside of here. And let me go ahead and, do not disturb. And then I'm going to close this old file and we're going to go ahead and open up our new one. Now, I like to start with the R Markdown. If you've been working from the book, there's also this data viz visualization notes that come along with the package, SoakViz, once that's installed. But for this purpose, I'm going to start with a plain document for the R Markdown. I'm going to call this chapter 5 homework. All right, and I'll go ahead and create that. And then again, we get this kind of template that tells us some of the basic features of the Markdown. I'm just going to go ahead and delete most of this. I'll keep the setup function, but most of it I don't need. Okay, so for this one, remember that we're going to use our libraries. So I want to install 2 libraries. Install them if they're not already there, but the ones I want to do are SoakViz, and I also want to load my library for Tidyverse. And I'm going to go ahead and run this, make sure that both of those run. If you're getting an error, remember that to load packages, you should go here and install packages, and you can type out the ones you want here to install from the CRAN, the repository network. Okay, great. So I have my 2 libraries, and then I'm going to go ahead and save this file so that I keep a working copy of it. I'm going to call this chapter 5 homework. All right. So to begin this chapter, it's going to talk a little bit more about geomes and how we make a series of commands using pipes. So pipes are very useful because even though they're an interesting symbol, they can help us kind of do a series of functions together. And so today we're going to learn about these summarized group functions. And what's nice about this is you can take things like these individual data and notice that you have a column here, and each has a variable. Well, let's say we wanted to kind of organize that and summarize it overall. So let's count all of the individuals by each region and each religion, and then the N will represent the number of people that are counted. And then within those counts, we can also take percentages. And in this case, we did a percentage by group. So we're going to be doing this kind of setup for a lot of things. This is very important if you want to create tables for summarizing your data. So the big things that we're going to focus on are these functions down here. So the group function, this is where we kind of set which variables are our groups, and by putting them in different orders, we can create a hierarchy of groups. We also have the filter function. This is really useful for removing observations based upon their status of a particular variable. So for instance, if I only wanted the respondents from the Northeast, I could filter it by just Northeast. And so that filters out the rows, which are your observations. You can also use the select, which will filter out columns. So let's say I'm only interested in 2 variables. I would use select to remove those 2 variables, or keep those 2 variables rather. And then we also have the mutate function. This is kind of like a nice function to create new variables from ones that we already have. So it's used a lot for calculating percentages, and it also makes for a very nice kind of way to refactor your codes. And then summarize will take one of the groupings, the highest level, and then calculate a function based on that. Usually we use either the mean, so let's say you want to take the average within a group, or you want to find the number using a count. So we would use n as a function. And for that one, we would summarize and then count the n, and it would count within each of the groups. So let's look at this example here. So we're going to try and create a new table called religion by region, REL_BY_REGION. So I'm going to go ahead and add that down here. So I'm just going to put a header and say chapter 5. And then for this chunk, I'm going to do the first one, which is I'll call this a sample table. And this isn't really related to the visual that we're going to use later, but it is a nice feature that I think I should show in this video. So let's create our table by naming it first. And then we're going to assign the outputs of these pipings to that variable. So we're going to take our data set on the General Social Survey data set, GSS_SM. And we're going to add some piping. So we're going to add these little symbols. It's percentage sign, greater than sign, and then percentage sign. And that creates a new line. And what that's going to do is basically hold this object as kind of a placeholder and say, this is my data. And then the next function I'm going to do, just assume that the data will be carried on for the next function. And you can do this over and over again. And what's nice about that is instead of having to kind of assign lots of things, and every time you do a manipulation, you create a new object, instead you can kind of stack them on top of each other to create a string of functions that all work from the same data set. So we're going to do the group by function, and this is where we're going to use the big region and the religion variables to create groups within our data set. So before we move on, though, let's just see what this GSM or GSS_SM looks like. So I'm going to select it. I'm going to do Command Return or Control Enter, depending on what kind of computer you have. And as you can see, I get 280 or 2,867 rows. So that's how many observations were in this data set. So each of those observations is a person, they have an ID, and then you can kind of see what other properties that person has. So as we go across, let's focus on this person. Looks like this is from 2016. Their ID was 11. Not sure what ballot is, but they are 33 years old, 5 kids, 4 siblings, have a high school degree. Yeah, the same one. Black female from the Mid-Atlantic. Their income is less than $1,000 a year. They're Protestant. It looks like they were never married. This looks like high school. This is more education stuff, it looks like. And then what their party ID is. So strong Democrat. They don't have political views, or they left it blank. And you can see if they're happy with their partners, as well as some other things here, like they're Leo, their zodiac sign. So this is great. It gives us some information. As you can see, there's lots of different things. It can also, I think this data set in particular has whether they voted for Obama or not in the presidential election. So US focused. So let's try and pull some more information out of this. So this calls up the data set that we just looked at in this view, and then it's going to group the participants by which region they're from and which religion they identify with. Next, we're going to create a new line, and we're going to go ahead and use this other function, summarize. So what this is doing is going to go down the list and count up how many people are within those groups. And so to kind of read this, you can use either the British spelling or the Americanized spelling for summarize. But then in this function, what it's doing is it's saying, make a new variable called n, And that n will equal the product of, or the outcome of this function. And this function with little n parentheses simply will count within each group to create a number that reflects how many people identified per each region, per each religion. Good. So if I run this as is right now, it looks like, oh yeah, and so it did save it. So now I'm going to call up my thing. So yeah, as you can see, now I can see that each region has shown up once, each religion has shown up, and it shows me how many people in my data set there are. You know, if I totaled up all of the people, it should be equal to the number of observations. And note that it also keeps track of the NAs. So sometimes you might want to remove those in your analysis. Okay, so let's keep working with here. We're going to do the mutate function. And what this is going to do is create a new column that we kind of specify, and it can take the outputs from the last function and now use those within our function. So since we know that everything's grouped, we can kind of use that as an advantage. And I'm going to create two new variables within our kind of summary table here. So I'm going to create one called frequency, FREQ. It's going to go here, and it's going to give me the relative frequency. So it's going to tell me how many Protestants are in the Northeast relative to the total number of survey respondents in the Northeast. And so that would be the number of that particular grouping divided by the sum within the group. And then for percentage, I'm just going to take that same number and times it by 100. So I go from a decimal to 100. But I also have to add this function called round, which will kind of remove extra decimal places if it gets too much. Good. So, and as you can see, it's already asking me for how many digits I want. So I'm going to call that to 0. And so what this should do is give me the frequency as a percentage by timesing the decimal by 100 and then stopping it at the 0 place mark. Okay, so let's go ahead and run this. And again, if we want to actually see the object, this first part just stores it as an object, but to call it up, we have to have it be recognized here. So there we go. So we have our big region, our religion. We saw the n from earlier, and now it's calculated out the frequency within each of these groups. So you can see 0.32 of the respondents in the Northeast are Protestant, and that comes out to about 32%. PCT is percent here. And as we can see, if we just looked at the Northeast, we should be able to add up to 100% here. So this is a really useful task for making these kind of summary tables and helping us to kind of take a large amount of data and turn it into a digestible piece of information. So we created the new object, we used the group by function, we used the summarize function, and we were able to make that new table. Okay, so the next thing we want to do is treat this as a pipeline, right? And so we can use this to build a plot off of it now. So now that I have all my data in a table, rather than like reconstructing from the raw data each time, I can use the summary table and continue to build off of it. So I called up my object here. I'm going to add some more piping. And now what I want to do is do another group by function, big region. And again, that's going to specify what the highest level of the group is. I'm going to add some more piping. And actually, for sake of clarity, I'm going to create a new line so you can kind of see that this is the data. This is the data being used with a group by function. And then the next one will use all of these grouped by data to do the next thing, which in this case, we can do summarize. So again, we're going to create a new variable called total, and total will sum up the percentages within each group. So hopefully these should all add up to 100. It looks like it went a little bit over here, 101. That's probably due to rounding. Good. So we took our summary table and we summarized it some more to confirm that each region added up to 100%. And now, as you can see, we can also create a figure from this. So let's say I want to create a new line here. I'm going to store my object as P for this new ggplot that we're building. The data will be the one that we just made with the relationship table. And then we're going to assign some aesthetics using AES. And first we have to specify what X is going to be. X is going to be by the big region, since that's a variable we want. And then Y, we can specify that as the percentage, PCT, since everything is turned on to that linear scale. And then for fill, let's make each of the colors the different religions. All right. Next one is P, and then geom call. So this means that we're going to call up the ggplot and use the geom call to put the ink on the page. So this will make a column graph. So columns can be abbreviated by col, C-O-L. So again, we're going to specify some extra arguments here. So position is going to be dodge 2. This will give us, so it doesn't stack everything. It'll put it side by side. And then we'll add some extra layers here. So we got our labs, X equals quote region, Y equals quote percent, and then fill equals religion. Great, so we'll add another one. Let's add the theme. That's just going to move the legend into a nice position in the center at the top. So legend dot position equals quote top. Okay, so that should be enough for us to create our graph. So let me go ahead and run all of this. Yeah, there we go. So notice that, first it's going to give me a notification of what it's summarizing by. Then it's going to give me the table that I made here. And then it's going to give me my graph for each region. I have each religion represented by different colors here, and the relative percent within that region for each religion. Good, and so that looks just like their table. Looks like our key might be a little bigger, but overall, pretty close. Okay, so we're going to keep going here. And play around with this a little more. So remember last time we learned how to do facet grids. So let's make this data a little more fun. And actually, let me go ahead and make a new, here, I'll call it sample table and figure 5.2. And then we'll go ahead and copy this chunk down. Now playing with coordinate flips and facets. Okay, so this is going to be figure. I'm just deleting a lot of the stuff that we have already because this will all be saved. We already have religion by region up above. And so it's when we call it again, it'll be down here. That should be fine. Next, I want to add some more arguments here. So it looks like instead of the themes, we actually give rid of the guides altogether. Which makes sense because, it's kind of like we have these labels and they're a little redundant with the colors. So why not just use them as columns? And so notice that instead of the regions being on the axes, now they're going to be faceted that way. So now we put religion up here. Religion for the X aesthetic. And then the fill will still be religion. So there's a little bit of redundancy there, but that one's actually okay because it helps us kind of encode the differences within each graph. It looks like for the X now, we're just going to remove since religion's not there, or since religion will be covered with the axes here, we don't need to say that this is religion. I think it'll be obvious enough. As a design choice, oftentimes less is more. Trying to remove clutter, distractions, so it's just focus on a strong signal. So now, so actually before I start adding these other ones, let's just run this and see what it looks like, make sure it works. Yeah, so now we have Protestants, Catholics, Jewish people, none other. So lots of different ways that we kind of flip these. And let's go ahead and add the coordinates so you see what this function does. So what this does is it's going to take the x-axis and make it the y-axis, give it a 90-degree rotation. So you get something like that, which is great. And then, of course, now we need to facet it to really help break up the regions. And this should make things look a little nicer. So I'm going to do facet grid and then tilde big region. Good. All right. So that's basically what we want. Now this looks kind of off. The big way to fix this is the book, I think, uses a minimal theme.minimal or underscore minimal. So if you want to make it look a little cleaner, do stuff like that. It gets rid of the gray background. But I'm going to keep it without it since that's what the code looks like. So notice that these coordinates can be flipped. This is another layer that you can play around with. There are other ways to kind of mess with the coordinate system too. So let's focus on kind of using this group by and categorizing functions more. So we're going to move on to the next section. So I'll just call this like 3 tick marks, section 5.2. And I should add some space there. So we'll move on. Actually, let me add another section header up here so we know that it's consistent. Chapter 5.1. And a little hint, if you ever need to navigate within the outline of your document, you can use these here. And if you're using the hashtags to mark your headers, they'll follow the same hierarchy that you have within the document. All right, so let's go down here. So it looks like we have a new data set we want to work with. This is from organ data on organ donations. So we'll go ahead and create a new chunk. You can insert the chunk either by typing it by hand, or you can use that little button there up in the top where it says insert. So I'm going to add this chunk. I'm going to name this organ data, since that seems to be the data set we're working with. And it looks like we already have some piping here. So now we can see what the select function looks like. So organ data. So on its own, this is, again, pretty large. It has 238 observations. And it looks like it's separated by different countries, different years. So we have a lot to work with. And then as you move across, so we can see that there's a lot of different countries represented here. But as we move across the variables, looks like we have even things like GDP, health, the roads, different laws, and then the consent about whether or not consent is needed to remove somebody's organs for donation or not. Okay, so let's go ahead and kind of summarize this. So it looks like we're going to focus on only the first few columns. So select will remove any columns that don't meet our criteria. So when I do 1:6, it's going to keep columns 1 through 6. So 1, 2, 3, 4, 5, and then 6, and it'll cut away the rest. And then we're also going to add this extra little piping here for our second function, which will be sample underscore n. This is a convenient way to take like a sample of the data set. So we're going to randomly pick 10 different observations from this data set. So as I run that, notice now I'm down to 10 observations. They look for randomly picked observations from different years. It looks like different countries showed up, although there's some repeats. And as I can see, I only get the first 6 columns. So I have country, year, donors, population, and population density and GDP. So there's nothing else after that. So select is really useful if you want to kind of narrow down your data set to only the things you want. Okay, so let's turn this into a scatter plot like is shown here. So P, ggplot, data equals Oregon data. And then maybe we can do mapping. So we're going to assign the aesthetics, AES equals, AES is a function. And then X is the first argument. We're going to assign that to year. And then Y will equal the donors. So I think this is a percent, or maybe it is the total number of donors actually, yeah. Sometimes it's hard to track the documentation of these data sets. I'm guessing it's percent of population that has agreed to have donors. Okay, so, and then we're going to add the P plus genome point. It's going to take the ggplot and then turn it into a scatter plot based upon the X and the Y values. All right, so there we go. We get our ggplot. Looks like we got this nice kind of scatter plot, and it's pretty similar to what they have there. Ours is a little more blown up because I have zoomed in. Okay, but notice that this doesn't really tell us much. We can't see the different countries. There's no way to really discern a trend. If we drew a trend line, it would probably just go straight through and, you know, not have any correlation or anything. So let's see if we can kind of pull out individual countries. So that's where this group by function comes in handy, and we can again use the faceted aspects to help us. So let's create a new line here. And I'm going to call this one figure 5.5. All right, so rather than keep working with that, I'm going to just focus on the ggplot. And here we're going to, you know, it looks like we have the same things. The only difference is instead of a geome point, we're going to do geome underscore line. And we're going to add some groupings to the aesthetics. So for this one, aesthetics, group argument equals country. So we'll have our first layer within the data will be the country, and then we'll add some facet wrap to pull out the countries so that they each have their own little plot, own little data plot. And let's see how cute that looks. Okay, nice. And so notice that it's in alphabetical order. That's kind of the default for these strings. And it does look kind of crowded. Let's see if I make this a little bigger though, I should be able to see the years better. Yeah, so that's nice. So as default, it's going to try and squash everything to fit in our viewer. So oftentimes this is a better way to kind of look at the data. The other thing you could do is when you run these, sometimes the viewer pops up too, which can be useful. Like if you were to put this in the console, it would work for the viewer. So I'm going to copy these just to show you different ways that you can visualize your data. So this comes out here, and then it gives me some export functions if I really wanted to work with just this figure. All right. So I'm going to clear that though, because you really don't need that. And I'll also clear the console so that we just focus on the R markdown. And that was a good time to save before we get too deep into it and have to restart. Okay, so we got our Oregon data. It looks like we were able to show some trends across different countries and, you know, how they're moving over time. So I'm going to insert a new chunk here. Actually, let me copy the one that we've been working on, because I think we're still going to stick with the same data set. So now we're going to do figure 5.6. And as you can see now, they're using what are called box and whisker plots. So box and whisker plot helps to show the distribution. Usually when you look at data, it's not all in one place. Like a bar chart might imply the average is here. but some values are above that, some are below. So what a bar chart fails to do, but a box and whisker plot does really well, is show you kind of the range of values. So we use standard deviations above and below the median to represent a box and whisker plot. And then two standard deviations out are at the end of these, what we call whiskers, this single line. And so most of the data, probably about 95%, is within this range here, from the top to the bottom of the line. And with most of it being around here, within one standard deviation above or below the median, contains most of the data. So if you think about that, each of these has kind of like a histogram popping out of the page, if you were to think about it as kind of spatialized out at you, with most of the density hanging out around the median. And for each country, they have different medians, so that's why they're going up and down like that. Okay, so how do we create this plot? So again, it looks like we have donors and country, so we need to first specify our axes. So let's do country and then donors. So that's very good. And it looks like the only thing left is a box plot geome. And so that'll make the ink so that it shows up like we see here. And voila, we have the same kind of box plot. So let's do the tricky thing again. We're going to flip the axes and get a little wild, turn things sideways here. And to do that, we just add this extra little command here, coordinate flip. And hopefully that runs. Let me go over and double check this. Yeah. So that looks good. So what's nice about this is now we can read those countries a little more. So whenever you have this kind of crowding on your axes, it's nice to separate things out and make it so that you can read, especially when names get really long like this. This is a good strategy. So up and down, this makes for easier comparisons of the data. But in this case, it's really hard to compare when you can't even read what you're doing. The other thing you'll notice is all of these are in now reverse alphabetical order, which is probably not the most meaningful organization for them. So as you can see, the next thing we're going to do is fix the order of these. So let's go ahead and do that. I'm going to copy what we have, make a new chunk down here, call this figure 5.8. And looks like we can remove kind of the NA values for one of these arguments here. So let's start here. So now instead of X just being the country, I'm going to do a function within it called reorder the country. And this function reorder, let's see, I'll type this into console so you can see what this looks like, reorder. That should give us the help page for it. I'm going to hide that again. So reorder, this is from the stats package, which comes with R. So reorder is a generic function. The default method treats its first argument as a categorical variable and reorders its levels based on values of a second variable, usually numeric. Okay, so it's looking for two arguments. The first one being some categorical variables, like in this case, countries. And then the second one has to be the same length, but it's going to determine the levels for the first one. So let's do that for this. So reorder country. So in this case, country is the variable we want to reorder, and we want to order it by the donors. And here's where we're going to remove NA. So na.rm is the function that we specify to take away missing data. Going to put some parentheses there. So it's looking a little weird. That's just because, I'm so zoomed in. There, that looks a little better. But I'll keep zooming in since it's better for the resolution. Okay, and then next thing we need to do is remove the labs. So we'll add another argument here, labs. And we'll get rid of the X by assigning that to null. So null is an empty data set. And there we go. Okay, so you can see Spain is now #1, and then we go down in descending order based upon the number of donors for these values. So that looks really good. Great. Now, what's nice about this is it really helps to show kind of bigger trends, and you can get a sense of the list here, which ones had the highest organ donors and which ones had the lowest. So next we're going to do figure 5.9. So again, I'm going to come down here. I'm going to paste what we have so far because it looks like we only need a little bit of color. And to do that, we're just going to add an argument after the y equals donors, and we're going to say fill equals world. Now there's some fun things you can do to play around with this. Let me add one other thing here. I'm going to do the theme. Legend equals okay, so let's see if this works. Nice. So we have nice colors. I think these are, can't remember what world represents. I think it's their government or the worldview or something like that. And we'll go ahead and save that. Now, the next thing that we want to show is there's a little cool, there's some fun things you can do. So distributions can get pretty difficult to visualize. So there's some other ways you can do this. You can do the geome violin. That'll create kind of like a small mirrored histogram within it, so you can see where the densest parts are. This is what is really meant by the box plot. It's going to show the same thing. We can also do geome jitter. This is one of my favorites because it shows all the points and kind of scatters them about. But it's oftentimes not that useful. So here, if I do this with color now, you can kind of see just where all the points fall. But we're going to go ahead and keep that as the box plot. I think this is still probably the cleanest looking visual that we can make right now. So if you're following along, this is about as far as you need to get for the homework. As I kind of showed, there's some extra things you can do to mess around with the dots and show the distribution a little in different ways. So if you want to play around with that, I recommend reading the rest of this chapter. But I think we've done a pretty good job of showing you the capabilities of using the group by functions and how to turn those into some plots that you can work with. That's all for today. And don't forget, you need to knit the document and make sure that there are no errors that pop up as you do that. And it should update your file. Once it's all done, you'll get this viewer. And again, it shows all the work that we did. You know, if you want to hide some of these things, you can set echo. You can also say include equals false. Message equals false. So these are some of the global settings. And then what that would do is just run the whole thing without showing you the messages or the text or the code and just the figures. Hopefully that's all you need. So export that. Your file should be saved here. And so hopefully you've been able to see this, and you can open this up in a web browser. And this is what you submit. All right, well, hope you enjoyed this video and best of luck